For part B of this question, they're asking you what is the average distance from the origin to a point on the polar curve. So a lot of people, we've done this question before, a lot of people were pretty confused about what does this mean, the distance from the origin to the point on the polar curve. People were using arc length formulas, people were using vector distance formulas, total distance formulas. But if you think about what this means, the distance from the origin to a point on the polar curve. Here's a point on the polar curve, here's the origin. How far is that if I have the point r theta? Well, if this is the point r theta, this distance is just r. So they're really just asking you, what is the average value of the function r? So what we really need to be thinking about is that the average value of r is given by 1 over b minus a times the integral from a to b of r of theta d theta. So this time the r is not squared. So to do that, this is my I need to know my b and a. They're still 0 and square root pi. So I'm going to do 1 over square root pi minus 0. Of course, I could just put square root pi if I wanted. Integral 0 to square root pi of my r of theta d theta. And I have most of that in here already, so I can sort of just copy and paste that. Especially, I can take advantage of my mistake that I made in part A, which is I forgot to square the r1. So why don't I just use that one? And so now I have the 0 to 2 pi of everything except instead of 0.5, I should have this 1 over square root pi. So let's delete that, and we'll delete the decimal, and then we'll insert 1 over square root pi. And yeah, that should be what I have here. Looks like what I have here. So again, I'm taking advantage of the fact that my r1, I already have that in a function. So I can just hit enter and it should give me the value, which is 1.5799. I'm under my restriction to round or truncate to 3 decimal places, so I could put 1.579, but I'm going to go ahead and put 1.580, and that's it for that part.